carbon emissions thing. They don't talk about the prototyping battery tech much. You think they'll make a large telescope fitting into Starship? Nero, they designed the payload bay knowing full well what you need to launch a defense payload into space. SpaceX actually bid Starship for the NSSL LSA. True story. They lost. The Air Force said, another shuttle? Yeah, no, hard pass. True story. The evolution of the Ford car. That's a cool poster, Hired. Alright. Let me just flash the title card for a second here, dudes, and I'll switch the title and we'll go. I'll be honest with you guys, I did not get as much done as I wanted to there. On the other side of Space News, dudes, I have to... Yeah, Space News is hard stop at like 6 o'clock. It's hard... Space News is stopping at 6, so in an hour and 36 minutes. So, let me flash the title card here, starting soon, and just put it up here enough for Drummer to be able to see it. Let's just play a quick song and we'll go. All right. Let's see. Was there links for Space News in there? No. We'll just keep this. So, okay, if you're watching this VOD for Space News on you know, or just watching the VOD for Space News, first of all, like, we had a, we were, before this Space News segment began, we were talking about payload capacity to Starship, and that's, I think, where we'll pick up the conversation today. Let me just get... We haven't talked about Starship in a little while, but we'll work on that. There is some other stuff. The Europa Clipper announcement is big. Okay, there is some Nauka stuff that you guys linked up, and yeah, more Starship stuff. There we go. Okay. I will stay awake just to witness this miracle. All right. The Ariane 5 launched slow-mos with good technical umbilicals cam. Nice, floating. Cool, cool. I'll leave it open, dude. And if we have some extra time during space news, we know that. I mean, we know that's not really gonna freaking happen. I'll check it out. But yeah, I gotta do racing tonight. So space news needs to hard stop at 6. We need at least 5 hours of good, solid Kerbal play. This isn't space news, but it's the greatest video I've ever seen. Nice. Okay. So I'm going to start space news with this. This happened a couple, like basically a half hour ago for the most part. Check this out. So NASA awards launch services contract for the Europa Clipper mission. So Europa Clipper is a orbiter and a lander that's supposed to go to the Jovian moon, Europa, and orbit and land on it eventually. So NASA selected SpaceX and Falcon Heavy to be able to move this mission to Europa in 2024. Now, there's a little bit of weirdness with this whole thing. That's cool news. I'm happy that we have a launch vehicle for Europa Clipper, but there is some stuff to note and some stuff to understand here. Europa Clipper was basically the brainchild of a politician named John Culbertson. I think that was his name. Let me just make sure. I don't want to do the rest of this thing. I think that was his name. So, yeah, okay. John Culbertson, this guy. So, listen. Now, once again, I ain't trying to make this into some Rule 8 thing. I'll just tell you what's going on and you decide, okay? So, John Culbertson was the champion of the Europa Clipper. John Culbertson was in the House of Representatives, and he was a representative from Texas's 7th Congressional District. So basically the area around Johnson Space Center, right? He worked super closely with JPL and Johnson, and obviously JPL in California, because it's another NASA center, and his own district to get Europa Clipper on the books. Culbertson worked extremely hard to push for Europa Clipper to also be an SLS mission. For an SLS to launch Europa Clipper to Europa. Now, he lost his seat in the, 2018 midterms? His seat got bumped and he got replaced with another politician named Lizzie Fletcher. I don't know much about her, but needless to say, John Culbertson, I don't think, and I'm not trying to talk bad about anyone here, just he was the one that championed this idea, and I think when he lost his seat, his spot in the representatives to Lizzie, I don't think that Lizzie had spaceflight as high on her list as a national priority, and that's fine. It's okay. You don't go barking up some stupid politicians, not stupid politicians. You know what I mean? Don't go barking up some politician's tree. All right, unless you live in Texas's 7th Congressional District and you personally want to see Europa Clipper happen. I mean, it's already happening. So don't bother. We're not doing that here. That's lame. That's Bush League stuff. So John Culbertson got replaced, and he got replaced before he got Europa Clipper on the books, but he got replaced. He got voted out by his constituents before he could really solidify Europa Clipper being launched on SLS. And then, after he left, there was a push to take Europa Clipper and get it off of SLS due to SLS's exorbitant price. And give it a commercial option, okay? So, that is ultimately what happened. Europa Clipper was pulled off of SLS by NASA, and they manifested it on a Falcon Heavy mission and gave it to SpaceX for $178 million. The SLS mission, it was thought of that total cost involved, important thing to understand there. Total cost involved would be about $1 billion for the launch. And I get it, before people go, huh, $1 billion? It just, yeah, it is a lot more money. But there's other things to talk about with that is important to understand. And once again, I'm not trying to say that you should have launched it on SLS or you should have launched it on Falcon Heavy, okay? I'm just telling you guys what happened, okay? So, when Europa Clipper, so they decided to put it on Falcon Heavy and they decided to take it off because of SLS's exorbitant price. And now they've awarded it to SpaceX for $178 million. Now, there's a lot of people, and rightly so, that think that's a good idea. Like I said, I'm kind of indifferent. I don't care as long as it launches. Just more things launching into space, the better, right? And more SpaceX stuff. I get to see another Falcon Heavy landing. I'm totally on that. That's cool. Now, okay, so the thing to consider here is that SpaceX is doing this for $178 million. It's way cheaper, right? Of course. But consider this. I'm drinking some water. SLS would have cost a lot more. The reason why it would have cost a lot more is because it's a way freaking bigger rocket than Falcon Heavy. It can move way more payload into space than Falcon Heavy. Even the Block 1 configuration has 30 tons on Falcon Heavy in terms of payload capacity. The Block 1 version of SLS has 100 tons to low Earth orbit payload capacity. Right? Now, that's 100 tons, not including the ICPS on top. The ICPS on an SLS rocket is payload. So you have a 30-ton Delta V, you have a 30-ton Delta 5, not Delta V, ICPS on top, and then you have a 25-ton Orion and service module on top of that. That's the payload. Anything on SLS that's above the core stage is payload. That's just by definition. SLS can get the ICPS, the European Service Module, and Orion into space fully fueled. So that's one thing to consider. SLS has way greater payload capacity than Falcon Heavy. Like I said, Falcon Heavy can do 62 tons into orbit in expendable mode, and it can do, I think, in reusable mode where you get all 3 cores back. It's a fraction of that, but it's still good. SLS, because it's expendable, can put way more payload into orbit. Now, consider this. Is Europa Clipper a heavy probe? No. It's pretty normal sized. It's a pretty normal sized probe. I think this mission will be fully expendable, sadly. Well, that actually helps what I'm trying to explain. This mission, that Falcon Heavy mission, will be fully expendable. Fine. So, fully expendable Falcon Heavy is 62 tons. Fully expendable SLS, obviously, as if there's another version, is 100, give or take. And it's going to need an upper stage. So, we'll just consider that. 62 versus 100. All right? Now, once again, is Europa Clipper a big probe? No, not really. It's pretty normal sized. You could launch it in a Falcon 9 and get it into low Earth orbit if you didn't want it to go further. Therein lies what I'm trying to tell you. They didn't launch it on John Culbertson didn't want to push to launch it on SLS because it has to go on SLS. It has to go on SLS because we need to get our money's worth with SLS. I mean, even though that's a pretty valid reason. The reason why there was such a big push by John Culbertson and, the people at JPL that he worked with to get this mission on the books and try to get it onto SLS is not because it's a big probe. Now, guys, you tell me, per the rocket equation, what happens if you have a smaller payload on a bigger rocket? The rocket's payload capacity is 100 tons. You have 5 tons of payload, and you launch that into space. What does that equal to? So what does it equate out to? If you're taking away payload mass and keeping the fuel mass the same, you get more delta V. You can accelerate faster. They didn't need to launch it on SLS because it's a heavy payload. They wanted to launch it on SLS so they could get it there on a reasonable time frame. And therein lies what I'm trying to tell you. Everybody's touting Falcon Heavy. SLS would have cost $1 billion. That would have, we'd have $1 billion. That $900 million, we could use it somewhere else. Falcon Heavy's only $200 million. We saved $800 billion, right? No, not necessarily. Because Falcon Heavy, even though it's launching in expendable mode, on Falcon Heavy, it's most likely going to have to do a grav assist off of another planet. Why? Falcon Heavy does not have the Delta V to move that payload out to Europa. It's going to have to grav assist. I'm almost positive of this because physics. Orbital mechanics is a hell of a drug. It's going to have to grav assist off something if they want the mission to, if they don't want the probe to use up all of its fuel before it gets to Europa. So, and that's the reason why they're launching Falcon Heavy expendable for the Europa Clipper mission as well. The reason why they pushed for SLS to launch it is because SLS will get it there faster. And that's what I mean. At face value, everything looks like we saved $800 million, right? But that's not necessarily the case. Now, because Falcon Heavy, because it needs to grav assist, it's going to take like 6 times the amount of time to get there. Because that's freaking orbital mechanics. That's how it works. It's going to take, not 6 times. I don't know. That's hyperbole again on my part. I don't know how much longer the Falcon Heavy is going to take to get there over SLS. I know that SLS could basically do a direct insertion to Europa with the Block 1 variant. And that's why they pushed for it to be on SLS, not to give SLS missions. They didn't do it. They did that so they could get the science done faster. And if you get the science done faster, that means that every dollar invested in putting that payload into space and getting it there is more bang for your buck. The yields would come quicker because Europa gets there faster. You learn quicker. If you learn quicker, that's less time that these scientists need to be sitting around doing nothing. Because it takes a while to get to anywhere in the solar system when you're using conventional propulsion. When you're using chemical propulsion, it takes a while. That's freaking physics, man. Unless somebody wants to invent warp drive or something, it's insurmountable. If we can bend the fabric of space and time, then that might not be the case. But, if we couldn't do that already, they ain't telling us that. Not saying it was aliens. But, so, NASA, what happens is when you have a science mission, generally, you have all these people that build the thing, right? They build the thing, they put it together, they package up the payload because it's usually a one-off payload, like going to Europa or New Horizons or OSIRIS-REx. Those people stay on that team basically throughout the entire tenure of the program. So the lesser amount of time that a scientific program lasts, right, i.e. the faster you can get the science done, the more bang for your buck you get in the long run. Even though SLS is more expensive, now because it will take, twice as long to get there, right? It'll take twice as long to get there. You're taking that $800 million and you're definitely not saving it. Now don't get me wrong, I don't think we're gonna spend $800 million on just paying scientists, right? Because the scientists that work on the probe and develop the probe are going to basically they're going to launch it and then they sit there and wait. Now, don't get me wrong, they can work on other things, but they're still getting paid to be on that project team. You're getting paid to be on the Europa Clipper mission and you basically don't do anything for a long amount of time. You're still getting paid to do it though. Just like the Perseverance guys. The Perseverance guys basically, they self-admittedly sat there and did nothing while Perseverance and Ingenuity were coasting out to Mars. Now, don't get me wrong. I don't necessarily think that the extra time that Falcon Heavy is going to take necessarily covers that huge cost deficit between launching SLS and Falcon Heavy, or over Falcon Heavy. But I do think it's important to understand that anybody that sits there and says, "Oh, launch it on Falcon Heavy. It's much cheaper. It's much cheaper." That's in notoriously bad faith to tell it like that, to say it like that, because you saved money on launch costs, but you moved money somewhere else. Now you're just paying a bunch of scientists to sit there and do nothing while it takes twice as long to coast out there. See what I'm talking about? Now, don't get me wrong. There's merits and demerits to both sides of this argument. And the big thing is that I think even launching it on SLS is still too expensive comparatively. But there's a fundamental problem with comparing SLS's sticker price to Falcon Heavy's sticker price. Differences. Why? SLS is an in-house NASA rocket. NASA is designing it. NASA denoted the design and Boeing made it, right? So it's NASA's design that Boeing made. Falcon Heavy is SpaceX design that SpaceX made that launches a NASA payload on top of it, right? So it's commercial service. SpaceX is a contractor in this regard. SLS is an employee in this regard. Employees are always going to be more expensive than a contracted service. That's why contracted services exist, so you can keep costs down, right? That's the idea behind putting it on Falcon Heavy, and that's not a bad idea. But if you have a contractor try to do what an employee at your business is going to do, well, then the price is going to go up. You didn't save money here. You didn't save money because now you're treating a contractor like an employee. See what I'm talking about? That's, at face value, I can already see it coming. Everyone's going to report this as, oh, SLS would have been $1 billion a pop. Falcon Heavy only was $178 million. That's the price of the contract. No, that's the price to launch it. That's the price to put it into space, because SpaceX charges launches at an at-cost, not an at-cost value, but they charge per launch. The SLS launch is not, it's graded on a different pay scale, just like you would pay a contractor different from an employee at a company. SLS is going to cost more because you're getting the total cost involved. So what does that mean? You're going to put your rope clipper on top of SLS. That $1 billion price tag that everybody loves to tout, right? That's the entire cost of the entire program from start to finish. It's an end-to-end cost, what's called total cost involved in economics. You're getting the entire thing. It's not just about putting the rocket on the pad, moving it to the pad, or putting it on the mobile launcher, moving it to the pad and launching it. It's the mission, it's the launch vehicle, it's the VAB maintenance costs, it's Michoud's maintenance costs because that's where SLS is made. Aerojet Rocketdyne needs to make new engines, right? We need to make COPVs for this thing. We need to make all the electronics, all the avionics. We need to make the solid rocket boosters. Northrop Grumman, we gotta pay them. And they're not just gonna foot the bill for the maintenance fees on their solid rocket booster facility to produce stuff for NASA. No, that $1 billion price tag per SLS launch is the end-to-end cost. SpaceX, when they charge for a launch and they negotiate a contract, you're not looking at that. You're only seeing the value to put that thing into space. They're not taking into account total cost involved. And that's why it's really stupid to compare SLS's price to Falcon Heavy's price. Now, once again, don't get me wrong. I think that Falcon Heavy is probably still less expensive. But my one kind of thing here, which is why I bothered to explain this at all, is can you put a price on science? Can you put a price on science? Well, in this particular scenario, because we're comparing cost involved to contracted services, yes, you can put a price on science. Your price on science is denoted by the price of the launch vehicle. And if anything, you're increasing the price to get science done because the program is lasting a lot longer. You're not getting the best bang for your buck that way. I'm pretty damn sure. A good example would be James Webb. The James Webb Space Telescope has been going on since I was in middle school. That program, over time, has cost $10 billion. 10 billion, B. Over the last, 15 years. That's literally the budget for like a constellation program. That's the budget for Ares 1 almost. You see what I'm talking about? Letting these science programs last longer means over time, there's a critical threshold point where the bang for your buck and the program still going is going to cross, and you end up spending the same amount of money that you spent before. Because Europa Clipper is going to take more time to get out there, that's more idle time for the scientists that work on this mission. but they're still getting paid for it. So that $178 million contract fee is not total cost involved. You're looking at one piece because it's a contracted service. You're not taking into account what it costs to run the program. And don't get me wrong, that $1 billion for SLS is not doing that either. But the $1 billion SLS launch is not going, because SLS is a way bigger rocket, and it has way more Delta V with Europa Clipper on board than Falcon Heavy does, almost exponentially because you have a Hydrolox upper stage, way more characteristic energy from SLS. It could get Europa Clipper out there in probably, if I'm, okay, napkin math off the top of my head, a quarter of the time that Falcon Heavy would take, and it can get it done, and it can get it done quick. And that is why you pay $1 billion for that. See what I'm talking about? James Webb, it's also important to understand with James Webb, that $10 billion doesn't even include the launch of the vehicle. The launch is free. Arianespace and Kinez, because we're working with the ESA on James Webb, footed the launch. That's their contribution to the program. The launch costs, they're footing the launch costs. So the James Webb Space Telescope, that $10 billion doesn't even include the launch fees, because the ESA is footing the bill for the launch. It's a free launch. There's no such thing as a free launch, but see what I'm talking about? Now, don't get me wrong. People are going to disagree with me on this, and that's fine. And I still will contend to say that I don't think that, that program is going to be 800 million over the next couple of years, or however much longer it takes Falcon Heavy to get there, right? I don't think it's going to take that. I don't think it'll reach that critical threshold point that I was talking about, but it could. All right. Anyway, let me keep up with chat. So once again, it's cool that that's cool that the mission is on the books. It's cool that they're launching it. It's just there's a little bit of background stuff to Europa Clipper that people should consider. Hey, 12, what's going on, man? Don't check Twitter. All the space news guys are saying that. Yeah, because they don't understand how cost structuring works at NASA. Either that, Phil, or they do, and they're just being willfully ignorant to it, which I'd like to think that everybody here at least argues in good faith. I don't know for sure, though. Yeah, James Webb, and I'd pay for it again. Less expensive isn't better. It's Delta V could cause mission failure. Unlikely airborne. You want to see what a $10 billion firework is going to look like? Bandit, what's that link? Eric Berger says, with the money SpaceX just saved NASA, the space agency can fund about 9 months of SLS rocket development. You're welcome. Yep, as predicted, Bandit. Was it because of cost? I thought it would have been because of SLS availability. Phil, that probably had something to do with it, I'll be real with you. It probably had something to do with it. But we're 3 years out from the mission. You're telling me that NASA can't, we can't get more RS-25s in that time? No. We could if incentivized correctly. I.e., if they gave the mission to SLS, they would have it. It might end up launching in 2025 instead of 2024, maybe. But even then, I think even if you delayed SLS a year and launched it later, SLS would still get it there faster. Also, it's a huge test if it launches on SLS, it can see actual capabilities. SLS, being an expendable launch vehicle, is inherently really good at moving payloads to the far reaches of the solar system. You know why? Because it's not reusable. All of the Delta V, all of the characteristic energy from that can be used to shoot a payload further into space. Framing it the way they did is sure is a good way to sell it to the taxpayers, though. Look how much money we saved. Please don't vote us out. That's what I mean about arguing and illustrating this point in good faith, Mile High, which is why I understand the position that everybody's taking when it comes to this. But it's important to consider in this particular case, because of the prior drama, I guess, from the Europa Clipper mission, it's important to understand why this is the way that it is. At face value, it seems like we saved a lot of money, but that might not necessarily be the case. Scary. So how is the scientist waiting for an SLS launch better than a scientist waiting for it longer on orbit? Falcon Heavy being able to launch Europa Clipper right when it's ready compared to Europa Clipper waiting for an SLS to be ready is a huge possibility. Yeah, Scary, we'd have to compare massive payloads here and time it in transit time, honestly. At that point, it's a transit time argument. I still think that we could have another SLS on the manifest by 2024 for Europa Clipper. By late 2024? Sure, absolutely. We could do that. We're 3 years out, man. You think we can't do that? Actually, that really would kind of depend on Artemis 1. And I suppose in that particular framework, yeah, if we couldn't launch Europa Clipper until 2026, then that kind of does make sense. But Scary, once again, this isn't the first time that this has happened. We've switched payloads off of rockets that have higher C3 in the name of cost, and we switched them to SpaceX because SpaceX is a lower price. That's not necessarily the case. You're not saving money necessarily in that regard. Once again, I think I'm doing the math out in my head, and even taking into account transit time, SLS still might be at the very, very least, it might push if it's delayed by a year. If it's delayed, then yeah, that doesn't really make a whole... Well, what I said doesn't make a whole lot of sense, because I was taking into account that SLS would be ready to launch at the same time that Falcon Heavy would be. Any news about Nauka? There is some, Laforte. I'll get to it in a second. And by the way, long time no see. What's up, Zep? I look more happier? Yeah, cool. Thanks, man. Why not use Delta IV Heavy? Couldn't it do it? Delta IV Heavy transit time wouldn't be that much lesser or more than Falcon Heavy, to be honest with you. See last, please. I have more links. Okay. Oh, Jesus. Okay. I'm trying to keep up. Sorry, I had to explain that out correctly. 12, thanks for the 20-month resub. I appreciate it. I guess they found more money for the HLS competition. Yeah, but Havix, the other thing to understand is that surplus cash when it comes to a government program like this. So, if you save $800 million by not launching the payload on SLS, and this is another important thing to understand. Now, once again, some people are going to be over here on this, some people are going to be over here on this. I'm kind of right down the road. Like, time is going to tell. That's the honest truth. Time is going to tell us if we save money on this, right? It's important to understand that $800 million that they would have spent launching it on SLS, that they saved, is probably not going to NASA. Yeah, it's not like NASA has a slush fund where they can just say, oh, we saved some money launching this on SLS. We're going to put this towards the lander program. That's not how that works. That $800 million that was saved is going right back into the coffers for the Fed. Not the Fed, but you get the idea. I wish it were possible to create a craft in orbit and link it up with another one to blast off to another moon. It is possible, Airborne. We just got to figure out how to do it right. Constellation was going to do that type of architecture, but we saved $30 billion again. What saving money does at NASA is cut jobs for engineers. Give me a second and I'll pull up a WBS for you. Like I said, there's the argument of saving cash, which is what I said first, and then the other thing is that literally that's less money for NASA. It is less money for NASA. These folks that are saying like, oh, whoa, look at how much money we saved. Is NASA about profit? And the argument there is that you're getting the best bang for your tax dollars are Mile High. You said it. You could pitch it that way to the taxpayers, but okay, so that $800 million that could have gone to NASA for scientists, aerospace engineers, whatever, right? Now is probably going to find its way into the defense budget or something. it's probably going to go somewhere else. I mean, less money for NASA. That's what I mean. It's the whole $30 billion argument. It's the same thing. You know, yeah, we saved $30 billion and we cut NASA's budget like crazy in the 2010 Authorization Act by canceling Constellation. Where did that money go? Where did those $30 billion that we saved go into? It probably went into some idiot politician's pocket. Now, don't get me wrong. It would do the same thing if it was at NASA. But at least NASA hires engineers and stuff, and NASA actually gives you some kind of return, right? It's not about price, but the probability of launch schedule assurance. I have zero faith on NASA in that regard right now. Fair. Once again, fair point, fair point. Side note, SpaceX just won a contract. And once again, I'm not saying that SpaceX is a bad idea. Scary. The points that you're saying are very right. There's two sides to this argument, and it's important for you guys to weigh which one you like. Go to page 96 for the WBS, and you can see what the mission costs look like. Page what? Page 96. I'll check that out in a second. FAA news. What's that? Want to follow the process of Sierra Space Co's proposed plan to land their Dream Chaser vehicle in Florida? You can now receive an update. Cool. Cool. NASA isn't some ambiguous business where a large sum of money goes to the people at the top. The majority of NASA budget goes into the pockets of engineers and scientists. Saving $30 billion again, right? Sorry, the subject is a little bit borderline with Rule 8. Why? I'm not getting you to think. I'm not telling you that one way is better than the other, Supercraft. I'm telling you to think for yourself. And this is... I've never been shy about discussing space policy, and I've never been shy about talking about NASA's budget. Meh, I'd rather see SLS launch it just so you can get the payload there faster. Side note, SpaceX just won a contract to launch a NASA flagship mission. This is going to be very high profile. It's up there with Viking, Cassini, Galileo, MSL, and Mars 2020. Yeah, no, there are demerits and not demerits to both sides of this argument. Like, there's pluses and minuses across the board. What I'm trying to tell you is that in this particular regard, it's a zero-sum game, almost. Scary as you have a point with mission assurance and launching on time because there is a transfer window. And SLS will only be able to get the program there to get that payload there faster if it launches on time. Fair point. That's a very fair point. And that's another thing to mention, right? It's another critical thinking exercise. Sure, Airborne. Yeah. See what I'm talking about? But... And that's fair. I think that's totally fair criticism and totally a totally fair thing to say. However, it's important to understand that this literally means less money for NASA. Like, there's no... Yeah, you saved some money on launching this particular payload. That's great. That means... Now, once again, you do that under the guise of, like, oh, NASA is getting the best bang for their buck. Well, I've illustrated a couple of particular points where that might not be the case, right? And I'd have to go crunch the numbers if I really wanted to be 100% sure. Total cost of Europa Clipper, what the projected launch cost is for flight, etc., right? Okay, give me 1 second, guys. Give me 1 second, dudes. Right on. Cool, man. Excellent. What do they want to do with this mission? Go and... Europa Clipper is 2 parts. It's a lander on Europa to study Europa because there's water on Europa. There's ice. And an orbiter, too. This has been way more than 1 second. 1 second. I believe it would have been an as yet unbuilt additional SLS core. All of the 3 in the pipe now are slated for Artemis. You could have moved it around, Buck. Could move it around. What, Michoud can't? Michoud is like, oh, we only have 3. Well, okay. Here's the criticism to the SLS argument, and this is why Scary is saying that it might not be on time. The long lead items for SLS is the problem, and this is one of my criticisms of the SLS program is that right now SLS is using leftover shuttle parts, leftover shuttle engines, leftover shuttle solid rocket motors, leftover shuttle OMS engines for the Orion service module. The Orion service module has a shuttle engine built into the back. Yeah, it's an actual shuttle engine that flew into space. Once they run out of shuttle parts, they haven't really solidified the plan yet. Yeah, so long lead, they're starting to work on long lead items. One of the long lead items for future Artemis missions is the RS-25E. They're working on that right now. That's a big one right there. Now, don't get me wrong, you don't need that to launch Europa. You don't need an Orion service module to launch Europa Clipper, but you do need SRBs. And that's why, if folks are saying, even if they slate this mission to launch in 2024, it might be delayed. And if SLS does get delayed, yeah, then Falcon Heavy is way better bang for your buck. However, I think if they put the Europa Clipper mission on the books and said that the money was there, the additional money for NASA to finance another SLS launch, which they probably would have got had it been approved for SLS, they could move some stuff around and push that inadvertently could push the BOLE program into overdrive, or SLS cores that could lead to an SLS block buy. I think that's the reason, more SLS flight time, the more the thing flies, the price goes down. The price goes down, the easier it is to make. Well, not necessarily easier it is to make. You make more and it's easier to make. But yeah, it's, overall, they're saying they save money, but the reality of the situation there is that you could end up spending a similar amount of cash because the mission takes longer to get there. And then even if you do save money there and it doesn't equate out to SLS moving there faster or launching on time, that's still less money for NASA. I think then once again, this is why I wanted to talk about this. That's an important thing to understand. You're saving money in the interim here, but that overall is less money for NASA. That has been my critique of Constellation and it getting canceled for the longest time. Great. We went with commercial partners. Not a bad idea. Great idea. But scrapping our national program ended up gutted NASA's budget. NASA ended up getting more money. Or not more money. They ended up getting way less money than they would have in the first place. And look, I don't care if it's cutting science. I don't care if it's cutting SLS launches. I don't care if it's cutting anything. I do not want NASA's budget to go down. I don't really give a frick where that is. NASA's budget should not go down. If it goes down and you cut a program, that does not mean that money that you cut from said NASA program is going to go to another program. That's not how that works. And I think that's the fundamental thing to understand. We saved $30 billion on Constellation. That's $30 billion less that we spent on space over 10 years. And we are reeling from the effects of that because it took us 10 years to get Falcon 9 to launch people up into space. It took 11 for Starliner. See what I'm talking about? There's no way, even if, the money is inefficiently spent, there's no way you can tell me that NASA getting less money is a good thing. Not a good idea. How do these companies employ people? Do they just have people sitting around in a factory when they're not building a rocket engine only because so many engines go on one rocket? Yeah, goalie. Why do you think ULA got paid a contract, not a subsidy, contract to keep their pads operational? Dude, there were years where ULA got paid to be operationally ready and they didn't launch anything into space and they still got paid. That's what I'm talking about. You don't mention the downtime on this stuff. The Europa Clipper scientists are going to be waiting 2-3 times as long for that probe to get there. You can't fire them. What are you going to do? Transfer them to another program and then transfer them back? Change the pay scales relatively overnight? Lateral movement at JPL? That doesn't sound right. I mean, that sounds like something Google does or Facebook or whatever. Like, you have lateral movement. You can move from program to program. JPL might work like that in that regard. I'm not 100% sure. It would make sense if they did. However, you can't tell me that if a project gets on, or if a scientist gets on like a Europa Clipper program, that they're not going to pay them in the downtime. That makes no sense. Like, demo, if I was working on OSIRIS-REx, for instance, and right now OSIRIS-REx is coasting back home, right? And then I go and work on another project. Do I change my paycheck? So say I make $50,000 a year working on OSIRIS-REx, and I decide to go on, like, you know, I'm not needed on the OREX program anymore, and now I want to go work on New Horizons. And I switch to New Horizons or Perseverance. Does my pay change? Does it go up? Does it go down? No, it definitely wouldn't go down. That's not how even the government works. No, nothing works like that. You wouldn't take a pay cut going to another program. So the only thing I can think of is that they either lay these people off, they're a contracted service, or they go work on another program, in which case you're probably going to get paid the same, because no one's going to take a pay cut just because they want to go work on another program. I mean, some people might. So where does that money come from? If you're, you know, say I want to move to New Horizons, and the position that I want to work on for the New Horizons project should pay 45, right? I made 50 in the OREX, working on OREX. Now that project is going to end up spending more money because I moved over there. See what I mean? They don't just lay the scientists off and then rehire them when the probe gets to the planet. Longer transit time will build up in cost exponentially over time, because idle scientists, not even idle scientists, if you're in on a mission like that, you're basically gonna, you're getting paid. That's a solid paycheck until the mission concludes. Check out the WDBS hardware operations cost relation. It will probably surprise you. All right, what page did you say that was on? It's already 10 past 5. We gotta go. Page 96. Okay. What is this? Lunar-based outfit with interchangeability and expendability. Okay. What am I looking at here, demo? Correct, Buck. That's the real underlying problem here. Nobody wants to address the elephant in the room. Top green line. So for this program, what's DDT and E? Design, development, testing, and engineering. Yeah. Look at the operations costs, guys. Look at the operations costs. There you go. That proves my theory pretty damn well, if you ask me. The operations costs and keeping these people employed to work on the program costs almost as much as design and development. The flight price is nothing. Design, development, testing, and evaluation. So, I'd be curious to see the transit time and how much longer it's going to take on Falcon Heavy versus SLS. Because we definitely ain't saving $800 million. You know, I didn't think that $800 million deficit would be close, but demo, looking at the that cost breakdown for a lunar landing, I think that was for a lunar landing program from Cal Poly. It seems like operations are about 50% of your budget. So if operations are going to take twice the time now, well, guess what? Now your operations budget is going to balloon in cost. The real question is that ballooning of cost equivalent to an SLS launch? Lunar base design for last year's AIAA competition. Guys, I'm crunching these numbers in my head, and we're looking at different things here. Like, everybody's touting this as a good thing, but they're touting it in a good thing the same way they touted Commercial Crew as being a good thing in 2011. And don't get me wrong, it might be better for the long term. Commercial Crew might be better for the long term, but I mean, there's no way you're going to tell me that this is better for NASA. This is literally less money for NASA. Actually, that's not entirely true. It's the same amount of money for NASA with less capability. Hey, Red Munchkin, 15-month resub. Look at page 13. NASA Systems Engineering Handbook Revision 2. Okay. Falcon Heavy was probably a better choice since it lowers risk. Yeah, that's probably why they went with it, Demo. Hey, Red Munchkin, thank you for the raid. But you're not supposed to think about that. This is for the common person that sees that we save money. Yeah. And once again, Goalie, that's the whole reason why I brought it up. This, everybody's touting this as this big win, this big crazy. Oh, it's so much better. Commercial, right? You know, you're taking money away from NASA now, right? Like, it's an important thing to consider. Now, some people will consider what I'm saying and say, yeah, I still like Falcon Heavy. It's still a better option. That's totally reasonable. It's totally fine. But it's better to know that, I told you kind of both viewpoints on this Europa Clipper mission, and you've considered the points, and you're still coming out with Falcon Heavy. Not you, just people that are watching. That's totally cool. All I'm asking is that people consider the points here, because nothing has a full benefit all the time. Oh, we've saved money here. We've saved money here. We've saved money here. No. That always has a repercussion. Saving money someplace means you're spending it somewhere else. This is a zero-sum game when it comes to this stuff. Red, thank you for the raid, dude. I appreciate it. Let's see. Look at page 13. Page 13 on... Oh, for Pete's sake. SLS is crowdfunded by the taxpayer, Goalie. Oh, look! NASA's Systems Engineering Handbook. It's funny that you linked this, because I have this on my desk. Let me read. I have the same page. You guys can't see that. Let's take a look. Oh, interesting. Mission concept review, system requirements review, system definition review, preliminary design review, CDR, SIR, ORR, DRR. Okay. Percentage completed, cost expended, committed life cycle costs. It's a nerd life. If you haven't seen this today. Neat. What are we talking about? We're talking about the Europa Clipper mission. So, Soapbox, what are you trying to get me to look at here? Let me see. Table 271, or no, we need figure 2.5. Okay. Cost-effective considerations. The objective of systems engineering is to see that the system is designed, built, and can be operated so that it accomplishes its purpose safely in the most cost-effective way possible, considering performance, cost, schedule, and risk. A cost-effective and safe system should provide a particular kind of balance between effectiveness and costs. This causality is an indefinite one because there are usually many designs that meet the cost-effective condition. Design trade studies, an important part of the systems engineering process, often attempt to define designs that prove the best combination of cost and effectiveness. At times, there are alternatives that either reduce costs without reducing effectiveness or increase effectiveness without increasing costs. At times, let me read that one more time. At times, there are alternatives that either reduce costs without reducing effectiveness or increase effectiveness without increasing costs, okay? In such win-win cases, the systems engineer's decision is easy. When the alternatives in a design trade study require trading cost for effectiveness, the decisions become harder. Can you link this handbook? Sure. Figure 2.5 shows that the lifecycle costs of a program or project tend to get locked in early in design and development. The cost curves clearly show that late identification of fixes to problems costs considerably more later in the lifecycle. Conversely, de-scopes taken later versus earlier in the project lifecycle result in reduced cost savings. This figure obtained from the Defense Acquisition University is an example of how costs are determined by the early concepts and designs. The numbers will vary from project to project, but the general shape of the curves and the message they will send will be similar. For example, the figure shows that during design, only about 15% of the costs might be expended, but the design itself will commit to about 75% of the life cycle costs. This is because the way the system is designed will determine how expensive it will be to test, manufacture, integrate, operate, and sustain. If these factors have not been considered during design, they pose significant cost risks later in the life cycle. Also note that the cost to change the design increases as you get later in the life cycle. If the project waits until verification to do any type of analysis, or any problems found will have a significant cost. If the project waits until verification to do any type of test or analysis, any problems found will have a significant cost impact to redesign and re-verify. The technical team may have to choose among designs that differ in terms of numerous attributes. A variety of methods have been developed that can be used to help uncover preferences between the attributes and to quantify subjective assessments of relative value. When this can be done, trades between attributes can be assessed quantitatively. Often, however, the attributes are incompatible. In the end, decisions need to be made in spite of the given variety of attributes. There are several decision analysis techniques that can aid in complex decision analysis. The systems engineer should always keep in mind the information that needs to be available to help the decision makers choose the most cost-effective option. As noted at the beginning of NPR 7123.1, the systems... Okay, no, that's 2.6. So let's take a look. Cumulative percentage of life cycle cost against times. So, right now Europa Clipper is right here. It's PDR if I'm remembering correctly. Interesting. So cumulative percentage of life cycle cost against time over time. So this basically says that the further you get into a program, the costs, the committed cost will go up if you change stuff later in the program. So that means that Europa Clipper, because it's launching on Falcon Heavy, and Falcon Heavy doesn't have the same amount of delta V that SLS does, that you're changing your operations through disposal. You're changing this cost structural analysis here. Not structural analysis. You're changing the cost analysis over here. And the NASA Systems Engineering Handbook shows that changing operations through disposal is one of the most expensive things that you can do. That's one of the most expensive things that you can do for a program. If I'm looking at this right, anybody want to double check me? Is that Soapbox? Did I get it right? Concrete. Interesting thought experiment. I guess someone will run the numbers. Faster, more expensive boost on a limited knowledge rocket, or cheaper on a slower design that's more flashed out. Well, Concrete Monkey, that's from NASA's Systems Engineering Handbook, dude. The Systems Engineering Handbook says that changing operational timelines is one of the most expensive things that you can do. And I've seen 2 case studies here, one that was linked from a viewer in chat and one that was linked from Soapbox here, that correlate that theory. Long story short, Falcon Heavy doesn't have the delta V that SLS does. Falcon Heavy is going to take longer. It's going to take longer for the probe to get there. And because it's going to take longer, the costs over time will almost push. It's very close. Science missions get expensive during coast periods. Because once again, my theory is right. You still have to pay the people that are working on this program. That's why operations through disposal is one of the most expensive things. Well, yeah, Red, exactly. So if you change stuff and then throw stuff away, it costs more than not changing the stuff and throwing stuff away. And we wonder why SLS is so expensive, because it's literally Ares 5 Light. We literally changed everything about that design in 2011, and we're wondering why it's so expensive. Oh, dear. And that fundamental systems engineering test right there shows that changing the flight time on a probe, i.e. switching the rocket, even in a preliminary state, you're grading it on a totally different cost scale. Which is just, oh God. Man, I hope I'm not right about this. That would really suck. I'm not sure, Buck. It's scheduled to launch in 2024, so I would assume that the PDR or CDR is still completed at this point. Halfway through the article, it talks about timing. Raph, what is that? So, trying to look at a similar mission for the Juno budget. See, I'm not sure where this is going to fall, but... So, formulation, implementation, launch services, operations. Ops is the most expensive part, dude. Oh, for frick's sake. Well, not the most expensive. Implementation, including launch vehicle price, is still expensive. But you're shifting that from SLS to Falcon Heavy. You're just shifting that cost over here. And what was that other one, Fozzie? Let me take a look. Yeah, see, I'm right. That's the other side of that argument, dude. You're shifting the cost somewhere else. And don't get me wrong, I'm still coming down in favor of that shifted cost to operations. The shifted cost to operations is probably going to be, it's still probably going to be less than an SLS launch, to be perfectly fair. But having another there's another argument to that. Having the SLS, launching it on SLS will gain us more knowledge on how SLS flies. Launching that thing on SLS will get us you'll get more data, you'll get more understanding on how SLS works, and you'll end up recouping some of the stupid development costs that we incurred trying to make that thing. The development costs that I might add ended up being super expensive because we decided 10 years ago to do the same stupid thing that we're doing now. Save some money here and there. I'm telling you, it shifts. It all shifts, man. Oh, look at how much money we saved, guys. That's Bush League. That's Bush League economics, dude. You don't want to fly the flagship mission under the guise of understanding the launch vehicle. Fair point. So if we wanted to compare apples to apples then, what's a Falcon Heavy worth to expend versus SLS? That's the real math. Well, Mile, I've done calculations on it, dude, and I know I've done calculations. What I'm doing is comparing it to a space shuttle launch. We knew the price per launch, the price point for the space shuttle, not total cost involved. Total cost involved, the shuttle was really expensive to fly. But once again, that's the bill on maintaining the launch pads, keeping the lights on in the VAB, paying all the people that maintain the VAB, the mobile launchers, the shuttles, the OPFs, the runway, upgrades, operations. All that stuff is factored into the price because of how NASA grades, because they have to be transparent because a government agency. You're seeing total cost involved. Now, with that being said, the at-cost value of a shuttle launch is about $400 million, and that was in 2011. So adjust that for inflation. I don't know, $600 million for a shuttle launch. Now, with that being said, SLS is a little bit. It's complicated, but it's a different type of complicated. So I would say an at-cost value, being a very liberal estimate, would be that an SLS probably costs $500 to $600 million a pop. Yeah, for a stack, somewhere in there, and that's at cost. That goes down over time if you launch it more. So you'd say it's a mistake for NASA to switch Clipper to Falcon Heavy in the long run? It's not necessarily a mistake, Hip. And my whole premise of this is that it's not necessarily a mistake. But I'm not saying that it is or isn't. That's really where I'm at. I'm trying to show you guys both sides of this argument, and yeah, I'm trying to show both sides of this because there is good points to either side. And once again, I said it when I was going to cover this in the beginning that it's up to you guys. Berger said the payload shakes more on SLS. Oh, yeah, okay. The shuttle launched the Hubble Space Telescope into space. I'm pretty sure the Hubble Space Telescope is very susceptible to vibrations because if the lens isn't right on Hubble, then you have some problems. We know because, the lens had problems, but not because of the vibrations from the launch. That's the stupidest thing I've ever heard. Thanks for that, dude. That's not how engineering works. That's not the end all be all thing, man. I just don't get it, dude. Doesn't make any sense. But either way, I'm just trying to show you guys both sides, and I'm right about operations. Some viewers helped me figure that one out, and I appreciate it. I kind of knew, but also it's good to get some numbers behind that. For later, they took the nose cone off. That's the one with the door. Oh, interesting. Yeah, I'll check that out in a second. According to that article, the SLS program had been telling the agency's leadership that the torsional load, an essential measurement of twisting and vibration, was a certain value. However, after NASA performed wind tunnel testing, the actual torsional load value was nearly doubled for the SLS program estimates. Well, that certainly is a problem. Now, but, Hip, okay. that is a problem, right? So in that regard, Eric is correct. However, hear me out, okay? Yeah, I want to know where he figured that one out. Yeah, a source, dude. Trust me, right? Just on it. So, side note from that. So that tells me that SLS is still in development. And Demo said a second ago, you're not going to want to launch a flagship mission on an experimental rocket. And now that we did some critical thinking about it, I'm thinking that's the reason why they wanted to put it on Falcon Heavy and not SLS. Not because I don't think Price might have played a value into it in some way, shape, or form, but it's a high profile mission. You don't want to launch it on an expendable vehicle. That vibration testing thing that you're talking about, torsional load vibration on the payload during ascent, however, after putting it in the wind tunnel, that makes it seem like NASA, we didn't know it was going to do that. That's called developing a rocket. So that tells me that SLS even now is still under development. Which it is. It hasn't flown an operational mission yet, so it's still under development, right? Now, Hip, here's the twist. Here's where I'm gonna go in on this. Why is SLS still being developed? Anyone know? Why is it still being developed? Why is it taking so long? Gives NASA something to do? SLS is still being developed because we saved $30 billion by canceling Constellation. No concrete roadmap for SLS, dudes. No concrete roadmap, no deadlines until the Artemis program came along 7 years later. Why did we cancel Constellation? Oh yeah, that's right. One of the reasons why we canceled Constellations because we said that we could save money by having commercial people do it later. They could do it faster for cheaper. Yeah. Uh-oh. See what I mean? Zero-sum game, dude. Also because Ares 1 is a death trap in case of failure. No, that's incorrect, Kmir. The reason why Ares 1 gets such a bad rap is because they weren't finished developing it. The same kind of bullcrap thesis that they're trying to pawn off with SLS and torsional loads right now. The reason why Ares 1 gets such a bad rap is because they killed it midway through development. So there were pressing things that needed to be addressed. Vibration issues, launch escape system issues. Do you think NASA would have just said, nah, those are problems, but we'll still launch it anyway? Anybody that's peddling that, Ares 1 was a bad design is an idiot. They don't understand how development works for systems engineering. That's not right. That's not correct. See what I mean? That's the saving money side of this argument. It's a cyclical argument that all that does is end up giving NASA less capability. It's unintentionally handicapping NASA over a long period of time. I think that's a mistake. You disagree, Nazaruk? All right. That's fine. I don't care. How did you get good? Good at what? Streaming on Twitch? Because I did it a lot? I don't know. Wasn't there also the whole Jupiter alternative design proposed as well that later derived into SLS? Mm-hmm. You're spot on, EJ, and it's so frustrating. And Denny, here's the thing, man. I don't want to be the frigging squeaky wheel when it comes to this, man. I don't want to be the guy that says, no, that's wrong. No, that's wrong. And sound like I'm on some stupid frigging high horse, dude. I don't want to do that. But, my hand is being forced here. What the hell you want me to do? Actually, I think Donkey Kong's the best game. Donkey Kong sucks. In my opinion, NASA shouldn't be launching probes like that if it can be done reasonably with existing commercial providers. They should be doing big stuff that isn't economically viable to push the boundaries. Fair? Fair. That's a fair thing to say, Concrete. I agree. Yeah, I see. Once again, both sides of that are. That's something that makes perfect sense to me. Not just herder, we saved money. That's lazy. One other point is that it's saving the Europa missions budget money so that it frees up NASA's budget. That's not how that works. But that might be enough to convince someone in Congress more confidence in NASA. On the flip side, they might say, look what you can do with less money, and give them less. It's the second one, Cabin. And once again, the systems engineering book denotes that, and also canceling Constellation and replacing it with JTM is a very good case study into exactly the second thing that you said. Gary says we can do it. Gary's always talking, Sun Temple. I saw that Ares 1 would have projected solid fuel debris all over in case of a RUD, which the launch escape system wouldn't have been able to escape fast enough. Must be what they were referencing. Yeah, floating disk. I'm familiar with the case studies. There's two big case studies that plague Ares 1. One was a vibration, the SRB vibrations. So the SRBs they're very powerful for what they are. They also vibrate a lot comparatively to a liquid fuel engine. Now on the shuttle, they had two SRBs that were connected via a crossbar that goes through the external tank, and the same thing is on SLS. That crossbar acts as a vibration damper, and the SRB vibration cancel each other out to where it's in a nominal limit, right? Ares 1 had vibration problems because it's only one SRB. NASA was able to solve that problem with the external tank by using a cross member as a damper to dampen out the vibrations. Are people going to sit here and look at me square in the face and say that NASA can't solve a vibration issue? The other thing was the launch escape system, like what you're talking about. There were points in the abort scenario where if the windage was correct, the SRB plume would go through the capsule and the parachutes would go through the SRB plume, right? That was a case study that was done by the Air Force. The Air Force did not a case study, a trade study into that. So you're telling me that rockets sometimes are susceptible to wind conditions when they launch? Thank you. Yeah. Huh. Real revelation there, champ. Is NASA based on the NASA from Interstellar? I mean, no. I'm telling you, man. The only reason why Ares 1 gets a bad rap is it was canceled before development was completed. So there were issues that they needed to figure out that they didn't get to figure out because the project got canceled. See what I'm talking about? Putting it out there. Herder, SRBs are bad. Well, I just don't understand how people can be space fans and there are folks out there that are space fans or space journalists or whatever, and they're so ignorant to actually how this stuff works that it's almost like, and don't get me wrong, I'm not an expert on it either, but I did 30 minutes of reading to figure out that there's a viable argument saying that putting this on Falcon Heavy is overall net bad for NASA. It took me 30 minutes to figure that out. 30 minutes of critical thinking. It could be. It's not that it is, but it could be. It's shown in the past that historically, not statistically, historically. I don't like people that put so many freaking things. Historically, it's shown to have been an overall net negative, not a net positive. So, I don't understand, why touting this as just an all good thing, is the right way to say it. It's not. It's not potentially an all good thing. It's not smart. That's not smart. That's what got us in this mess in the first place, that kind of thinking. If we didn't spend our budget, what we didn't spend would get reallocated in different places for the next year. That causes fraud and waste and abuse. One of the reasons our military kept dwindling is that we could always spend because someone wanted to save money. Yeah, Airborne. Do we have any other space news that need to be covered before the deadline? Yeah, there's just Starship. I was gonna, yeah, John. We're just basically gonna limit this to some Nauka news, Starship, and this. No, Blueland. Well, dude. I don't want to say this. Like, it's not a good thing to say. But if you're touting this as such a good thing, there's very good, clear facts here that this is not totally a good thing in this particular scenario. But no, it's all good, right? Nothing bad. I don't like reporting the news that way. That's stupid. I don't like just reporting good or just reporting bad. News, just like history, should be reported apolitically. Not apolitically, because that implies there's a political bias here or something. No, it should be just you report it and you let the people that watch come to their own conclusion. Everybody's touting this as a good thing. While not wholly recognizing that this is following a trend that ends up with NASA with net less capability. Objective. That's the right way to say it. Hey, but see, on the other hand, they might be right. I don't know. You know, they could be right. My guess is that this has more to do with risk evaluation than anything. I think Skiri was right in saying that it could be more about, you know, launching on a not flight-proven vehicle versus a less flight-proven vehicle. In which case, if SLS launches and your Europa Clipper blows up on it, then Falcon Heavy was a good call, right? Like, I get that. That's fair. That's totally fair. Hey, Jensen, what's up, dude? Look at the Dyne map? Sure, man. What's up? Oh, very nice. Looks good. That's going to be a big building, man. Cool. Yeah, we're talking about Europa Clipper. Jensen, everybody's touting this as some great victory, dude, but I think it's important. The gist of it is that I think it's important to understand that this is following a trend with NASA. The whole, commercial can do it better, commercial can do it better, commercial can do it better. That whole argument ends up with NASA having net less capability. And this is entirely based off of a bigger thesis that I have, where we shouldn't just pawn off our entire national space program onto commercial providers. I don't think that's wise. Imagine how stupid it would be if we privatized the highway system, for instance, because the highway system can do it for cheaper. Or GPS or something. It's a bad idea. I don't think that's a good idea. I really don't think that's a good idea. It's not that it's a bad thing, Jensen. It could be a good thing. Falcon Heavy, you're reducing risk because Falcon Heavy is flight proven. That's the plus to that argument. You're also potentially saving money, but you're increasing operations time because Falcon Heavy doesn't have the Delta V that SLS has. Because it doesn't have the Delta V that SLS has, you're paying, the satellite's going to be flying out there. The transit time is going to take longer. If the transit time is going to take longer, the mission's going to be more expensive. And what you saved on launch costs, you're going to incur in operations costs. And operations costs, we've shown through a couple of different pieces of funding and through NASA's Systems Engineering Handbook, operational costs account for a very, very high amount of the program. That's a very, very big cost incurred. They're not the most expensive. Developing it is the most expensive. but it's the second most expensive part of any program, especially a scientific program. So if your transit time is double what it's going to take, your operations cost is going to balloon like crazy, to the point where it could make the money that you saved from launching it, it could make the money that you saved on launching it irrelevant. Anyway, that's all I'm going to say. I think I covered that pretty well. Once again, I'm not trying to say that it's one or the other, guys. I'm trying to illustrate both points. I'm trying to be middle of the road here. I think it's pretty obvious which one I think is the right move, but there are benefits and drawbacks to either side of this, launching on Falcon Heavy or launching on SLS. I think the biggest merit that the Falcon Heavy thing has for it is that it's going to launch on time and that it's going to launch on a flight-proven vehicle. Straight up. Those two alone is enough to put it on Falcon Heavy. That's enough to merit that argument, not even including cost. So, whatever one you think, yeah, I mean, it's important to illustrate both points. And I didn't really think we were going to discuss this today because I didn't, but it's something to understand. But wouldn't it launch in like 2026 plus if it went on SLS? Yeah, but Ark, that diagram from the NASA Systems Engineering Handbook denotes that if you change timelines at the beginning of the program, you can scale your cost better because 75% of the costs and structure of the program is allocated right at the beginning of the program during the development phase. Long story short, if you have a better idea of the timeline, you can scale your funding to that timeline. We just did the opposite of that. We scaled it for a time with SLS, pushed it forward with Falcon Heavy, and increased operational time. That will balloon the cost on the Europa Clipper program above original projections because of the high cost incurred from operations when it comes to Science Mission Directorate missions. I think that's a very, very viable thing to understand. Now, I'll be honest with you, I don't care. At the end, I don't care. That's not the right way to say that. At the end of the day, either one of these ways, I guess, is good. More rockets launching, more payloads is what we want. But yeah, it's important to understand that this is a net loss of cash and funding for NASA. You're getting less bang for your buck doing this. Even if you saved money from launching SLS, that is an overall net loss of funding that could have gone to NASA. And where's that funding going to go? I don't know. Who knows? Anyway, Starship news. Check this out. Yeah, exactly, Buck, and it comes back to my entire pay scale grading thing. Everyone uses SLS's price tag compared to Falcon Heavy as a point of argument when they're literally comparing millimeters to miles here. Oh, Falcon Heavy is 137 millimeters. SLS is... Wait, no, how would the argument stack up better? This one's 137 millimeters and that one's 162. Actually, the better way to... No, hang on. I screwed up the analogy. Rewind. Falcon Heavy is 137 feet long, but SLS is 147 millimeters tall. 147 is bigger than 137. This is the right one. This one's shorter. That's literally what's going on. You're changing scale here. It's like using two different units of measurement to measure one and saying that the one that has the higher number is bad because it's a higher number. That's not how that works at all. But anyway, payload bay doors. Pretty cool, huh? Now, don't get me wrong. I don't know. This could be a prototype. I don't know what it's supposed to be. It could be a hat that belongs on a band member of Devo. I have no idea. Yeah, it seems like that Mary took this picture this afternoon, and it very much seems like SpaceX has opted for a payload bay design with doors that open up like this, not like this, or like this. It looks like an elder hat. Oh, man. Mixing two units of measurement always works out well. Yeah, XP, especially when it comes to space flight, am I right? Sad Mars climate observer noises. What's up, Bagel Buddy? There seems to be a bit of it missing. Is Falcon Heavy frozen or could be improved over the years? It's not frozen per se. Major development is scaling down, though. There are some upgrades that SpaceX is going to implement to Falcon Heavy over time, like a bigger fairing. But yeah, for the most part, yeah, it's frozen. I mean, Elon himself said it's a dead-end architecture. This is the new hotness. So check that out. They, it looks like they have, I don't know if this is, it could potentially be for a payload bay that does this. Who knows? I wonder how the shuttle bay doors would work with the nose cone partially opened up, i.e. the payload bay doors extend into the nose somewhat. See, that's the secret, man. Shuttle's payload bay did that. It's just a little bit of an optical illusion that makes it look like it didn't. Shuttle's payload bay goes into the nose section of the shuttle. See the line that angles down? That's actually, of course, I found the most potato picture of all time. Because why wouldn't I? See, look at where the payload bay door is. The front of the payload bay door is curved in, so could they put it into the nose cone? Sure, absolutely. Shuttle did it. Maybe a Taurus version with a big window. That'd be cool, Gandhi. Yeah, that'd be pretty sweet. I don't think SpaceX wants to put that on their first prototype, though, you know? Yeah, of course they could. Starship could deploy radiators and solar panels with this. Yeah. They could make it go into the nose cone. I have my theories as to why, and we were discussing this before Space News, believe it or not. One of my theories as to why Starship could have, why the payload bay isn't going all the way to the front like it was in SpaceX's original renders, regardless of how the doors work, is because of mass, believe it or not. I think that Starship is going to have some kind of crew tank up here, similar to the shuttle, believe it or not. The space shuttle at the very front of the orbiter, right around, you know, well, where the people are, there's a huge pressure vessel. It's basically a pod that's flying inside of an aluminum cradle, and the aluminum cradle is the outer skin of the shuttle. See that? See the golden? That's the crew tank. I think that SpaceX is going to put some kind of crew tank up there or something. The reason why I think that is because it doesn't matter if you're making a re-entry vehicle that's designed to land on a runway, right? Oh, there they are encapsulating the crew tank. It doesn't matter if you're making a re-entry vehicle that's designed to land on a runway or it's designed to land propulsively like that. Center of mass and center of lift are still a very, very big deal when it comes to re-entry. We're learning that pretty well from the SSTO that we're making in KSP, right? I have a theory, and my theory is that, well, more mass in the nose cone of Starship for like a crew tank or whatever, and payload bay doors that go like this, still meet all the payload requirements for any payloads that are flying right now. The reason is because Starship's payload bay is freaking gigantic. Its habitable volume is ridiculous. Ridiculously high. So even if you took away the nose part of the payload bay, it's still a bigger payload bay than most rockets flying by volume. Right? Well, at least I'm pretty sure. Pretty sure about that. Max, if you're here, double check my numbers again. So I think that they shorten the payload bay, and they're going to see. I think that is a prototype or kind of an idea into maybe putting some type of habitable volume in the front. Now, I know what people are going to say. EJ, what are you talking about? More mass in the nose? Won't that make it fly worse? Well, no. The header tank's up there for a very good reason. More mass in the nose of this thing will move the dry center of mass closer to the payload bay. That will improve Starship's down mass capability and also improve its handling during re-entry. The further forward you can get your center of mass, or the closer to the center of the vehicle that you can get your center of mass, the better. Now, don't get me wrong. Starship can compensate for a rearward center of mass bias or a forward center of mass bias with its flappy wings. The flappy wings work like a body flap on the shuttle. Basically the same idea. They can be used to trim it out during re-entry, to basically move the center of pressure and the center of lift directly in line with the center of mass. So you can compensate for having an empty payload bay coming down or a full payload bay coming down. What I'm thinking is that SpaceX is going to try to make a shuttle variant or shuttle style variant of this in some way, shape, or form. Because why? So before you say, EJ, that's not how they work. You're crazy. Well, what else are they going to put up there? We know that that's hollow space. What else would they put up there? I'm interested in what chat thinks. We just finished saying how stupid it is comparing millimeters to inches. Please stop comparing Starship to shuttle. Yeah, that analogy doesn't hold water here with this at all, Swishio. You're the one that's comparing millimeters to inches now. Because the analogy for that was cost scaling structures. That has nothing to do with vehicle architecture. It's totally different. Vehicle architecture and design is something that's not the same. They chopped this nose cone like a half an hour ago. Does it even fly? It just kind of falls. I mean, Josh, the Starship, just like the shuttle or the X-33 or the X-37, is not really designed to fly well at all. It's designed to fly in subsonic conditions. It's designed to fly well in hypersonic conditions. You got a haircut, looking fresh. Thank you. Avionics, sure. Could put O2 up there. A dance floor? I mean, I wouldn't hate that. Fly or glide? It flies at hypersonic speed, guys. Yeah, it flies. Just like the shuttle flies very well going Mach 25. It does not fly very well going 250 miles an hour near the ground. It flies like trash down there. Starship doesn't even fly at all down here. It can't. It sucks at it more than the shuttle does. We are the Coneheads. We come from France. Yeah, the shuttle flew poorly down here. Starship doesn't fly poorly down here. That's the part where Starship falls. Discovery. Flying is an abstract concept anyway. All it needs is a purple lamp so I could grow your tomato plants in it. Nice. Yakim, 47-month resub is 42 plus 5. Facts. Did you know that we live in a society, Yakim? I mean, it's the exact same shape. Yeah, I said that, Tessa, when I first showed the picture. We live in a society, man. All right, 2-minute warning. Let's get through the rest of the space news. I'm going to see what's going on with Nauka. So it looks like the undocking for Piers was pushed back from Saturday to Sunday now. Let me go through this briefly. Okay, Piers was postponed today. What else do we got here? So that's indicating that they need more time for Nauka checkout. So according to a source, until he's actually saying, a potentially mission-saving firing of the DKS engines was scheduled between 21 and 21:30, or a half hour from now. This info is correct. Okay. And then this is coming from Katya Pavlichenko. My source confirmed the firing of the DKS engines in Nauka today was successful. Good. Another critical milestone. Very nice. And then coming from Jonathan McDowell, the orbit was changed from 224 to 347. From 224 to 347 to 225 to 363. This is not the orbital raise using the main engines that Anatoly reports was expected around 1800. That will presumably show up in the data later today. So it's the DK engines. Okay, got it. What else do we got? So the crew of MS-19 began to prepare for the MS-19 mission, which is launching later this year. Pretty cool. And then Piers was postponed for a day. And then this last article here from Dimitri. Let's see what we got. What what do we got here? Modernization of the launch complex for Soyuz 5 at Baikonur will begin in August. Negotiations on the Baitarek project were successful, and all major differences, all negotiations were finalized. I hope that in August, Roscosmos Ground Space Infrastructure Operations Center will sign a contract and begin construction work at Baikonur to create a launch complex for our newest Soyuz 5 rocket. Cool. Soyuz 5 rocket is a Soyuz family. It's in the Soyuz family of rockets, but it uses a redesigned first stage. Now, some will argue whether it's a Soyuz rocket or not because it doesn't have the 4 boosters on the side. A Soyuz 5 is a single stick rocket with a regular Soyuz upper stage and payload fairing on top of it. The first stage has an RD-180 in it. Or is it an RD-170? It was one of those. It has an Energo Mosh engine in it. And a friction stir welded core, which is that's really cutting edge for the Russians. It's good. That's right. The actress and the producer crew. This is the first time they suited up. Cool. 171 MV. There you go. They're working on the Baitarek launch complex. Baitarek is the old Zenit launch pad. Zenit was a carrier rocket that was derived from Buran Energia's 4 side boosters. Those are Zenit boosters. The Zenit rocket was a booster with none of the landing legs or anything on it on the sides and an upper stage on top using an RD-170. But the thing is that the Zenit design was made by Yuzhnoye, which is Ukrainian. So they're upgrading it for the Soyuz 5 launch pad. And that's cool. That construction will go forward with that in August, confirmed by Dmitry. That's good news. More launch complexes being used is not a bad thing. SN-20 seems to have been stacked here. So Zenit is Antares. The Antares first stage with the RD-181s in it is Zenit derived. That is made by Yuzhnoye. Yeah. Okay. Is VentureStar going to get a crane arm? Mine will, Zabaski. Yeah, I want to put a robotic arm on it. I'm trying to look around and trying to blaze through the space news because we got to finish up like now. So they did take apart that nose cone with the payload bay on it. So, guys, I'll be honest, with that Starship nose cone payload bay, it's very possible that that was just a prototype. SpaceX could have been experimenting with the design. They might still go with the chomper fairing. Who knows? We don't know for sure. I hope it wasn't a prototype. I like the space shuttle Starship thing going on there. The better question is that Starship getting a Canadarm. Wouldn't that be something? Wouldn't that be something, Jack? Will the Korolev Cross design be phased out? With Soyuz 5, yeah, it's a single stick. Yeah, that's Kem. Yeah, the MS-19 crew. That's the first time they suited up. So that's Klim Shipenko and Yulia Pereslid. And then Commander is Skap. Skap's cool. I like that guy. One of the first ISS missions that I followed very, very closely was when Skap, Terry Virts, and Samantha Cristoforetti flew into space. Yeah, so Skap's one of my favorite Russian cosmonauts. That's cool, man. Anton Shkeplerov is his name. I said when. When will the Korolev Cross design be phased out? I have no idea, dude. I don't know. I have no clue. Sometime in the next decade, maybe? Who knows? They needed a 1-to-1 scale cut-through model for their upcoming presentation for government officials. Yeah. All right. I think I got everything. I will leave you with this RGV aerial picture here. It's photoshopped, but also... Hey... So he photoshopped SN20 and what it's going to look like, and then he took Photoshop Booster 3 and put it on the OLM and put it all together. That's kind of what it'll look like, guys. That's not that far off. Yeah, MS-19 is going to launch later this year, Tessa. I think the Starship shuttle bay is for Hubble repair. Oh, don't tempt me with that, W. But, you know, that's a good point, dude. There is a very, very, very big demand up there for satellite servicing. And with satellite servicing, you need a crew tank, and you need a cargo bay, and an airlock, and ideally a robotic arm like what the shuttle had. So, guys, like, that may have just been a prototype, but I also don't think that, you know, shuttle-style payload bay doors on Starship is out of the cards here. But once again, that could be just wishful thinking on my part because I missed the space shuttle. It could be that. It probably is that, I'll be honest with you. But also, that would be really cool. I'm going to have the doors that open up like this. Like this. Or like this. Chat, do you know what this is called? It's called tres comas. Do you know what it means? No. It means 3 commas. Okay? Doors that open up like this. Like this. Not like this. You know what I'm always thinking about, EJ? If and how they're going to control the plume exhaust when they go to launch. In what regard, Nazareth? This is a milk stool design, dude. Here. When you move a rocket high enough off the damn ground, it really does not matter. If it's high enough off the ground, you don't need a flame trench. I mean, look at I mean, the Russians have been launching without a flame deflector for a really long time. They just hold the rocket over a big hole in the ground. Don't get me wrong, there is somewhat of a diverter down here, but if you're high enough off the ground, it don't matter. They could easily send a crew on Dragon to a starship that's in orbit acting as a service dock. Possible, Thailand. That would be cool. That would be really cool, actually. Starship's also got the range to go out to Geo and service and decommission satellites. They would probably do that unmanned, like remotely, Tessa, but yeah, you're right. I wouldn't send people out there unless I absolutely had to, because you have to get around the Van Allen belts. Big pain in the butt. When you're going to the moon, you can kind of go, you could skirt through the outside of them to get to the moon at an inclined orbit. Doing that to get out to Geo could be, unless Starship could come up with deep, like, not even deep space rad shielding, dude. Starship would need something heavier than that because the Van Allen belts are full of all kinds of stuff you don't really want to be exposed to. Yeah. I didn't get to that Space News article about Europa Clipper, but either way. One last thing is, Elon Musk's meeting with the mayor. Oh, this is bad. Chosen one. He's meeting with the mayor. Oh, again with the squeaky shoes, Elon. I wonder if they can approximate aerospike characteristics by throttling the outer Raptors on Super Heavy. Yeah, maybe.
Hi, I'm leaving.
Oh, okay.